In this lesson, we're going to be talking about graphing linear inequalities. We have to reflect back on the difference between an equation and an inequality. An equation has one answer, where an inequality has many answers, an infinite number of answers. So when graphing linear inequalities, we have to represent an infinite number of answers. What we're going to be doing here is we're going to be shading in a region on the graph. Let's go ahead and look at this first example. Y is less than or equal to negative 2x plus 1. So the first thing I want to notice is the symbol. The symbol less than or equal to or greater than or equal to means that it's going to include that point. What we're going to use for those two symbols is a solid line. Unlike if we had less than or greater than, this is going to be represented by a dotted line, meaning that the point is not included. Okay, let's go ahead and graph. I know that my slope in this problem is negative 2 and my y-intercept is 1. So let's go ahead and put my y-intercept as 1 and graph the slope. Okay. Now, the symbol is less than or equal to, which means that it includes the point. So what I'm going to do is go ahead and draw a solid line through those points. And of course with arrows at the end. Now, so far it looks pretty similar to just a regular linear equation. This is where the inequality part comes into play. I need to have a test point. I usually like to test the point 0, 0. So I'm going to go ahead and test this point right here. What I mean by test is I'm going to plug in that coordinate into my inequality. I'll do this along the side over here. So I'm going to test the point 0, 0. So I'm going to plug it into the inequality. 0 is less than or equal to negative 2 times 0 plus 1. These two are going to cancel out, and I'm left with 0 is less than or equal to 1. You can see that what it leaves me with is a true statement. If the test point turns out being a true statement, that means I'm going to shade all of the points that lie on the same line as the test point. So how I'm going to do that is I'm just going to go ahead and shade in that whole area. What that means is everything to the left here of this line, including the line, is a solution to this inequality. Now, the test point that I chose was 0, 0, but you do not need to test 0, 0. You can test any point that you want. Usually, when the line itself goes through the origin, I like to choose a different point. Sometimes I like to choose 1, 1 or negative 1, 1. Those are also good points to choose. Now, let's look at the bottom here. We want to know, are these points solutions? So let's look at the first one, negative 2, negative 4. Negative 2, negative 4 lies about right here. You can see that he's in the shaded region and therefore is a solution to the inequality. 2, negative 4. 2, negative 4 is in the shaded region as well, so therefore he is a solution. 1, 5 is about right here. You can see that he's in the non-shaded solution, therefore is not a solution to the inequality. Okay, let's try another one. Let's try the second one. Y is greater than 2/3 x minus 3. You can see that our slope here is going to be 2/3 and our y-intercept is negative 3. So let's go ahead and graph accordingly. Okay, so I have my points. Now I want to look at the symbol. The symbol is greater than, so I know that it's not included, which means that I'm going to represent it by using a dotted line. So any points that lie on that line are not going to satisfy this inequality. Okay, now let's go ahead and test a point. I'm going to go ahead and test the point 0, 0. So I'm going to go ahead and write that here, and I'm going to substitute it into the inequality. 0 is greater than 2/3 times 0 minus 3. So I'm left with 0 is greater than negative 3, which happens to be a true statement as well. So therefore, this point right here is true, and I'm going to shade on that side of the line. If it happened to be a false statement, what you would do is you would shade on the other side of the line from the test point. Okay, let's go ahead and look at these coordinates and see if they're solutions. 1, 2 is about right here, and he is in the shaded region, so it is a solution. 4, negative 5, that's about right here. He's not in the shaded area, so it's not a solution. And then negative 3, negative 5. Oh, he lands right on the line. But since he's on the line and the line is dotted, he is not a solution. Okay, let's go ahead and try these ones. These are our special graphs. All right, so this first one here, x is less than 3. So I'm going to go ahead and graph it like I would normally do this. I know that x is a vertical line, and it's going to be on 3. I also know that my symbol here is less than, so this is going to be a dotted line on positive 3. Now, unfortunately, you can't really use a test point here. You just have to kind of read it. X is less than 3. Well, everything that's going to represent less than is going to be on this side of the graph. So I'm going to go ahead and shade this area of the graph. These are all of the solutions to this inequality. Okay, let's try this one. Y is greater than or equal to negative 2. This is a horizontal line on negative 2, and it's also going to be a solid line. It's greater than or equal to negative 2, so I'm going to go ahead and shade everything above my negative 2. Those are all of the solutions to these inequalities. Okay, now let's go ahead and think back to when we were transferring different forms of linear equations into others. This one's in point-slope form. Let's go ahead and graph this. So there's a couple ways you could do this. You could take your slope out of here, and you could take your point and graph it that way. Or you could turn this into slope-intercept form. Your choice. It really doesn't matter. So what I'm going to do is I think I'll distribute. I think that sounds like a good way to go. So I'm going to go ahead and put this into slope-intercept form. Now I'm going to go ahead and subtract the 2 as well. I'm getting closer to slope-intercept form. Okay, now that I've transferred it, let's go ahead and plot it. I can see that my symbol is less than in the original problem, so therefore I'm going to have a dotted line, meaning it's not going to include that point. Okay, now let's go ahead and grab our test point. I'm going to go ahead and I'm going to do 0, 0 again. So I have 0 is less than negative 3/2 times 0 plus 4. 0 is less than 4. And again, it's a true statement. It's not always going to be true, but this one happens to be true. And therefore, we're going to go ahead and we're going to shade this area over here. All right, the last problem here, we have standard form. So let's go ahead and put it into slope-intercept form. So let's go ahead and subtract 5x from both sides. Negative 2y is less than or equal to negative 5x plus 2. Now, I'm going to divide both sides by negative 2. If you remember, the inequality rule that applies here is anytime you multiply or divide by a negative, you have to flip that sign. So it still applies in here. So y is greater than or equal to 5 over 2x minus 1. Let's go ahead and graph him. All right, I think that's all it's going to fit. It's going to be a greater than or equal to symbol. Now, if you look back at the original up at the top, it's less than or equal to. But we've flipped the sign since then. So we're going to go ahead and draw ourselves a nice solid line. There we go. And let's go ahead and do our test point. We're going to go ahead and use that equation here at the bottom in slope-intercept form. So 0 is greater than or equal to 5/2 times 0 minus 1. 0 is greater than or equal to negative 1. And it does, again, happen to be a true statement, so we're going to go ahead and shade everything on that side. All right, again, we didn't have any examples here of any false statements, but if it was a false statement, we would just go ahead and shade the other region. Okay, now we're going to go backwards. This really requires some thinking. Let's look at this first example. It says, determine the inequality in slope-intercept form. They give us the graph of an inequality. So here's how you do this. We want to set up an inequality, and we don't know what the sign is, so I'm just going to represent it by like a little circle. We'll figure it out. Now, y is on this side, so y is going to be something, and then my slope in this case is 1/2 times x minus 1. Now, to figure out the symbol, I have to kind of think here. Let's say that 0, 0 was my test point. If I substituted 0, 0 into this problem, I'm just going to go ahead and simplify this to just kind of show you. I get 0 is something to -1. We don't know what's in that box. But I know that the point here is a false statement because it's shaded in the other region. So I ask myself, how can I make this a false statement? So I notice that it's a solid line. And if I put a less than or equal to in there, 0 is less than or equal to -1. Well, that's not true. That's false. So I wanted to create a false statement. Therefore, the symbol will be less than or equal to. So I'll rewrite it as y is less than or equal to 1/2 x minus 1. This is the inequality that is represented up top. It's kind of like a way to think backwards. Let's try another one. I'm going to start off by just putting a y there, and then I'm going to leave an empty circle. And then my slope, it looks like my slope is -1/2 this time, plus 4. Okay, so I need to figure out the shading. So I see that 0, 0 is in the shaded region, so I want a true statement. So if I substitute 0, 0 in there, let's go ahead and do that. I get 0 is something to 4, and I want to make it true. Well, a dotted line would make it a less than. 0 is less than 2. That's true. So therefore, my symbol is less than. Now, I'm not done with this problem, and the reason is it's in slope-intercept form, and I want it in standard form. So let's go ahead and transfer it into standard form. I'm going to add 1/2 x to both sides, and then I'm going to multiply both sides by 2. And here is the equation. I'm sorry, I forgot to change my symbol here. Whoops. Let me go back and do that. I accidentally wrote an equal sign. Not sure why I did that. Okay, so what do we have here? 1/2 x plus y is less than 4. There we go. And then I'm going to multiply by 2 on both sides to give me x plus 2y is less than 8. This is my inequality in standard form of this graph. All right, that brings us to the end of our lesson on linear inequalities.